Welcome back to Mathuta, where we support your math learning. Based on our previous episode, we begin with episode 307. If you haven't watched episode 306, click on the link above. Trigonometric graphs. You may need to recall episode 301, standard position, episode 303, radian as measure for size of angle, radian versus degree, episode 305, redefining trigonometry, episode 306, trigonometry extended to any angles, and set theory unit 1 of class 11th text. You would also need to know the concept of a function. For now, we abstract a function as a mathematical machine that accepts an input to give a unique output. Functions that involve real numbers can be visualized on graphs with outputs against inputs. So a point on the curve that satisfies the equation of the function maps the input to its respective output. Let's look at sine as a function and visualize the graph of the sine function. In order to do that, let's get back to the unit circle and keep an empty graph ready for graphing. We begin with the angle 0 radians. The sine of 0 radians is 0. We mark the point 0, 0 on the graph. We plot the varying y coordinates of the point P, the sine of the angle shown, against the measure of the angle in radians, as P completes one revolution. We get the graph of the sine function between 0 and 2 pi radians. As for angles larger than 2 pi, notice a cyclic repetition of outputs. Therefore, on graph a repetition of the wavelet. And on extending the graph to the negative side, voila, we have the graph of the sine curve. So now that we know the graph of the sine function, we inspect all possible inputs called the domain of the sine function, and all obtained outputs called the range of the sine function. Since every angle has a sine output, the set of all real numbers form the domain of the sine function. The maximum output is 1 and the minimum output is -1. Hence, the range of the sine function covers all real numbers between and inclusive of -1 and 1. Now let's have a look at the cosine function and its graph. Let's begin with the angle measuring 0 radians. Remember, the output of the angle is the x-coordinate of point P. So we begin with the point 0, 1. As P makes a revolution, we obtain the graph of the cosine function between 0 and 2 pi. Extending the cosine function to angles beyond the interval 0 to 2 pi, we have the graph of the cosine function defined for any real angle. The domain is clearly the set of all real numbers. As for the range, we know the maximum value for cosine is 1 and the minimum value is -1. Hence, the range covers any real number between and inclusive of -1 and 1. Now that we have covered both sine and cosine, let's look at the graph of the tangent function. Back to the unit circle and a graph to visualize the tangent function. We start with the 0 radian angle. We know that the tangent is the ratio of the sine and the cosine of an angle. Therefore, we look at the output, the ratio of the y-coordinate to the x-coordinate of the point P. As we rotate P about the unit circle, we get the graph of the tangent function between 0 and 2 pi. When revolving P more than 2 pi radians and on revolving it the other way round, we have the graph of the tangent function defined on a larger platform. Look closely at the graph of the tangent function. We see that the function is not defined at minus 5 pi by 2, minus 3 pi by 2, minus pi by 2, pi by 2, 3 pi by 2, 5 pi by 2, and so on. The yellow lines are called asymptotes of the tangent graph. These are lines that never intersect the curve as such, and yet, apparently, seem like they do somewhere at infinity. Tangent is not defined at these inputs, odd multiples of pi by 2. Notice that minus 5 can be written as 2 into minus 3 plus 1, minus 3 as 2 into minus 2 plus 1, minus 1 as 2 into minus 1 plus 1, 1 as 2 into 0 plus 1, 3 as 2 into 1 plus 1, 5 as 2 into 2 plus 1, and so on. A family of numbers 2n plus 1 where n is any integer. And so, the tangent function is not defined at 2n plus 1 times pi by 2 for any integer n. Hence, the domain of the tangent function includes all real numbers other than the collection of 2n plus 1 times pi by 2 for any integer n. The range of the tangent function covers all real numbers. Now, as a DIY drill, draw the graphs of the following trigonometric functions in the given intervals. Pause the video if you would like to try it yourself. Here are the graphs for the first three. Endpoints in dark highlight are part of the graph of the function, and endpoints in white are excluded from the graph of the function. The dotted red lines are asymptotes. As for the fourth, a piecewise defined function, which outputs sine x when x is between and inclusive of minus 2 pi and 0, and cosine x when x is between 0 and 2 pi inclusive of 2 pi. The graph is as follows. Did you get all of them right? This time, try working unscaled. Sketch the graphs of the following trigonometric functions for the given domain and write down its range. Pause the video if you would like to try it yourself. Here are the answers. Did you get all of them right? As an open problem, can you define a function that is described by the following graph? What do you think is the answer? Leave us your comments. If you like the video, don't forget to hit like. If you think it's worth a share, do share. If you wish to stay updated about new videos, do subscribe. Oh, and don't forget to leave us a comment if you want